Hey guys, hope you're doing well. Just gonna do a small review of exponential functions, just in case you're still having difficulty. So I want to recall that an exponential equation looks like this: y equals a times b to the x, where a is your initial value and b is your growth rate or decay. So right here, just a quick overview. It says give the value of b, then tell whether each is growth or decay. If I'm using this equation here, this tells me my b value is 0.5, which is 1/2. And since my b value is less than 1, right, this is called a decay. Right? That's why that's a decay. And here, this equation, y equals negative 1/2 times 8 to the x, this tells me my b value is 8. And since b is greater than 1, this tells me that I have a growth rate. Okay, so hopefully that clears things up if you have any questions. This next one says graph each exponential function, identify the domain, the range, the y-intercept, and the asymptote of each function. Okay, so here, my y-intercept, just in case you didn't know, is always in the format 0, a. Okay, and so in this situation, my a value is -3. Right? So since a value is -3, that means my y-intercept is going to be 0, -3. My asymptote is going to be the x-axis, which is y equals 0. Okay, my domain for this function is pretty simple. All real numbers, and we use that funky little r, remember? Now my range, on the other hand, is going to be y is greater than 0, or sorry, less than 0, because it's going down. Since the a value is negative, that actually flips the graph. So it looks something like this. So here's my x and y axis, and my a value is at 0, -3, so it's going to intercept right here at -3 value, and it's going to look something like this. And since that a value is negative, it actually reflects. This is called a reflection over the x-axis, so that means y is going to be less than 0. Okay, we have question number 4. Okay, and you notice that question number 4 is y equals 2 times 0.5 to the x. Okay, again, it's an exponential function. It's going to look something like my x and y axis. Okay. My a value is 2, so that tells me my y-intercept is going to be 0, 2. Because remember from earlier, y-intercept 0, a. So it starts off at 2 right here. Okay, and unfortunately, since b is less than 1, it's going to be a decay. So it's going to look something like this. Okay, my asymptote is still the x-axis, where y equals 0. Because it's going to be right here, this horizontal line. My domain is at all real numbers, because we're talking about a function, and then my range is y is greater than 0. Okay, notice here the a value is positive. This tells me my range, y is greater than 0. Okay, next we're going to move on to our models, whether it's growth or decay. So let's read through the question real quick. It says a new car costs $15,000 to build in 2010. The company's financial analysis expects costs to rise. Right, so that's a keyword, rise. That means it's going to be increased. So that means it's growing, right, by 6%. So this 6%, that's our R. But remember that that's a percentage rate, right? So we got to rearrange that when we put it into one of our equations. Okay, it's going to raise by 6% per year for the 10 years they are planning to build the car. Okay, so I'm looking at this model, right? We're going to go ahead and use f of t, so we can write a function of time. Okay, f of t equals, okay, well, what's my initial value? Well, in 2010, it starts off at $15,000. Okay, and then we're going to do 1 plus r. Remember, since r is 6%, really, r is actually 0.06, right? That's what r really is. So when I do this, it's going to be 1 plus, and the reason why it's plus is because it's rising. So it's going to be 1 plus 0.06 to the t, because t stands for time and number of years. Okay, so now you'll notice it says here, question B, what is the exponential growth factor? So it's looking for a b value. So right here I have my rate and I have the 1, so I'm going to combine these together to get my b value. So that tells me my growth factor is going to be 1.06. That's my b value. Now, how much will it cost the company to build the car in 2017? Well, this is 7 years after the year of 2010. So this is saying when t is equal to 7, because it's 7 years after 2010, right? Okay. So basically what you want to do is use your model. You want to find f of 7. So we put the function f of 7 equals 15,000 times 1.06 to the 7. So you would type this in your calculator like this, and you'd get your answer, which I typed in earlier, and I got $22,554.50. Okay, so after 7 years in 2017, to make this same exact car, it would cost them $22,000 to make. Okay, and notice that we did the 1 plus r, our growth rate model, because of the keyword here, rise. That's what we make sure we want to understand. Okay, now we look at number 6. Number 6 says, a business purchases a computer system for $1,500. The value of the system depreciates at a rate of 15% per year. So again, we have a keyword in here. It says depreciates. Depreciates means that I'm going for a loss. It means we're going to use our decay model here. Okay, and now all we need to do is find my rates. And it says a rate of 15%. Remember, this is 15%. So that tells me R is really 0.15. Okay, so it says write an exponential function to describe the situation. We're going to use the function for time based on the number of time, where time is years, right, per year. So f of t equals the original price, which was 1,500, times 1 minus, right, or 1 minus 0.15 to the t. Okay, our rate's actually negative 15% because it's depreciating. That's why we have a minus here. So it says, what is the exponential decay factor? Well, right here, we'll find our b by taking 1 and subtracting 0.15, which gives me 0.85 as my decay factor. How much is decreasing? Okay. Now, it says, what is the value of the system after 3 years? Well, this is telling me when t is equal to 3, what is my output, right? So my input is 3. Now I'm getting an output after 3 years. Okay, so we're going to say f of 3, so functions of 3 years, is equal to 1,500, excuse me, 1,500 times my b value, which is 0.85 to the t, or in this case to the 3, not the t. My apologies. So 1,500 times 0.85 to the, what we said, 3, right? And that gives us $921.19, and I'm rounding up, right? So this is approximately $921.19. So that's how much the computer would cost. That's how much the value of that computer would be after 3 years.